Right, this one's a bit different. I'm actually quite proud of it. It is still radio related. It's using computer aided design, 3D printing and external printing sources, etc. to produce a bracket that goes on the sun, or clips to the corner of the sun visor in my Vauxhall Astra to mount this radio. So this manual, as yet, has not been opened. I've just turned the radio on and used it. I haven't felt the need to look at that, but I'm sure that that is stacked full of useful features for me to look at later on and work out how to use the radio a lot more than I am already. So for now, let's take a look in here at what I've done. Okay, so this project started with the back of the Yaesu FTM-510DR radio, which is a mobile. It's a case of where do you put it in a modern vehicle with airbag city, and also where can you put it that's practical, that you can view it and use it. So I chose in my installation to have the head unit only up on the top, actually on the sun visor. Not directly on the sun visor, but on the pivot point. So the pivot point is, you know, where you have your sun visor in front of you and you snap it out of a hook and rotate it around. It's the rotate around point which is normally closest to the external of the vehicle. How do you get it there? What do you do? My first problem was, how do you even mount something like this to something? So the plan was to make a flat plate that sits across this back surface, has a hole in the centre there for I think it's, I want to say, an M5 threaded bolt or threaded screw, whatever it is, into that hole in the centre, but to fit a plate along the back there that wouldn't rotate in use and was sturdy enough to support this head unit. So here's my initial attempt, met the criteria, and what I discovered along the way here was dear old Yaesu didn't arrange those recesses on that back plate symmetrically. And you know, when you first take a look at it, you just look at it and expect it. When I CAD'd it up, taking the measurements from the screw hole in the centre to make this plate, which obviously slots in and won't rotate because of the extrusions from the blue plastic going into the indentations in the back of the bracket to stop it rotating. My first run at this, it didn't work, and I just scratched my head, and you just wouldn't believe this stuff. So let me show you the back again and see if we can see how it's not symmetrical. So on first view that looks symmetrical, but if you look at the bottom surfaces, left to right, they both are pretty much the same, but the tops aren't. They're kind of out of line, and that in my first CAD kind of threw me. But there we are, live and learn, measure, measure, measure. So many iterations later, look here, many iterations later, I came up with the final unit. So in my CADs, it's my kind of practice to save at various stages moving along, and you'll notice in the middle here, I start with the name of the project and T1, that's take 1, take 2, take 3, etc, etc. I think even just for the initial blue one that I just showed you, it was up to maybe like take 5, take 6, just minor jiggery pokeries, but it comes out. So in doing the the CAD work, I use a program called FreeCAD, which is absolutely fantastic. Okay, and this is the FreeCAD file here. Let's open that up. There we go. So this is my final version, take 21. So FreeCAD is a very, very good CAD program, comparable with the high-end ones, but guess what, it's free. So there's my final bracket. Just as an example of what you can do, or what you do with FreeCAD, is each part, or each part of the progress of your job, it will start at the top here. So I padded a main plate, so the main plate is this piece here, the long piece. If you expand each section, there's a sketch, and the sketch is actually what what you make on the screen there. And then in this case I've padded it, so if we turn everything else off, I wonder if we can turn, yeah, so there is basically what we started off with. And again, I can just rotate it on the screen, do whatever we want, but we basically start with doing this sketch, constraining it with the measurements. When you constrain it, everything turns green. You close that, and then with that selected, you perform an action here, which is 3mm. I could change that to 10mm. There it is, 10mm. You can go up, down, etc. Whatever, but our one was 3mm. And there it is. And then you just basically proceed with the rest of the action. So the next bit was to make a bolt hole. I specified where the bolt hole was there. It was 5.5mm, so yeah, that's probably an M5 screw that we were using. Where exactly on the plate it sits. You close that sketch, and then you run you can extrude or create a hull. In this case I created a hull, I forget the words for it. These are the extrude or pad tools, and these are the pocket tools. That's, yeah, pocket and hull. So this one here pads it up, makes it thicker. This one, whatever you put on the drawing, pockets it, creates a hole. And you basically build your CAD up from the beginning to the end through different processes. I've got a LAN cut out here. LAN was, if you remember, the LAN was obviously where you plug the LAN connector. Would they call it a LAN connector? I don't know. It's the data cable that runs from the transceiver unit to the head unit. But it is actually, I think it's like a Cat 5 or Cat 6 LAN cable, that's what it is. But I'm descriptive in my CAD here on each part of the process, and obviously I just collapse it down to make it simpler to look at. So there's the stages I've gone through, right down to the end now. But there's our end piece. So what we have here is this ring around the top that clamps around the sun visor hinge point. So there's a bracket that goes up into the roof of the car. It's a circular bracket. It's probably 2 inches across, and a couple of screws, holding it up tight. So I slacken the screws off. This ring slides between the bracket and the roof lining, and then I do the screws up again. And then in that way you have this bracket facing towards you like that, with the head unit attached to it. So this CAD software is FreeCAD. Let's not go into it any further, but it's absolutely fantastic tool for creating whatever you want to do. I use it for work as well, so I'm quite well versed in it. Okay, back to the pictures. So the progress, as I previously said, 20 takes before we got the final product. I 3D printed it. This was the final product in CAD. Looked quite cool. I've 3D printed it first of all, and while we're talking about 3D printing, just this first section alone, which fits into the back of the radio, I've uploaded it to Thingiverse, and I'm about to upload it to an alternative site whose name I can't remember, but I'll probably post on the screen now. So this is it, 3D printing on a K2, Creality K2 printer. There's the final version. Oh no, that's not the final version. This is my initial version, just to check for the alignment. This is one of my final versions. You'll notice the strands on the back there. That's because when you 3D print, whatever is upside down will have some strands hanging on it. It's just how it is. So you lay it in the slicing software. You try and orient it the best way you can to prevent that. But as I knew that I was going to print this in metal later, it really wasn't a problem for me. It was more just to check the alignment, and it was functional. So this is quite a good view. I've thought about this quite a lot. The entry point for the LAN I had to change slightly because I couldn't get my finger down to release the tab. So I removed some of the area there where you would be able to reach down. The other hole, it just aligns. There's nothing in there to contact, so it just aligns. That's okay. The upright support part, I've strengthened by putting a right angled, what would you call it, support plane, I don't know, into there to anyway strengthen it, stop it flexing from left to right. And then I did similar on the top, although it does have a weak point in this design. This is the weak point, and that's solved by printing in metal anyway at the end of the day, once this was proven. So I actually did fit this to the back of the radio and installed it in the car temporarily. It worked, it was fine, but the screen kind of wobbled a bit under vibration whilst driving along, and that's totally fixed with the metal printed version. So let's have a look where we went with that. So this was my initial installation with the plastic unit up there behind the radio. It works absolutely fine. It's functional. It vibrated a little bit, what can I say? For me, the only drawback with having a head unit here is it's up and out of the way. The sun visor folds backwards almost horizontally towards the windscreen, so it doesn't fold up forwards anymore, but backwards very minimal obscurity of the windscreen. So that's good. But yeah, in practical use when you're driving along, you wouldn't really want to control the radio, with a hand, etc. I can just kind of lightly tap, and it's okay. But the problem is, or my problem is refocusing. So I'm looking down the road. Obviously I'm making sure there's no vehicles coming the other way, or anything that's likely to be a problem while I'm adjusting the volume, say, but I look up at the radio, you know, just kind of glance up and then glance back. In those glancing, there's refocusing issues. Maybe it's because I wear glasses, I don't know, but just momentarily there's refocusing. So it's fantastic to have, good position to be, up and out of the way there. It's not sitting in the sunlight on the dash, and it's not in any airbag city, so it does work. So away from this, I then went on the back of this test proving okay, and I splashed the cache with JLC, which is JLC is traditionally a PCB print house, but they also take CAD stuff and print, and this is in metal. I couldn't tell you what metal it is. I should know, but this is what came back from them. It's basically a much tougher version than what I printed in Hyper PLA that Creality have. So there it is. It's basically, it's a casting really. It's 3D printed metal, but you know, it comes out with that slight texture, and it's a casting. But it does the job. It really does. It's very sturdy. This is the screen on the Creality printer itself, and it just shows that it's a 30-minute print basically. This was an early version before I'd fully boxed out the LAN connector, etc. Anyway, hope you enjoyed the video. It's given you some inspiration. Just try it.
So this video, if you like it or don't, comment down below a thumbs up.
Thanks for watching VA3SII. Bye.